So section 2 of chapter 2 deals with properties of water. Now water is considered a polar molecule because there's an uneven distribution of electrons between oxygen and hydrogen atoms. Because of the polarity of water, hydrogen bonds occur. So if we look at this diagram in the lower right hand corner, we see that the hydrogen side of water is positively charged. That's the little white circles, and the oxygen side, the red circle, is negatively charged. Now this attraction between the positive and negative end is what allows hydrogen bonding to occur. Now, polarity is going to have a major impact on whether or not things are soluble and whether or not things can dissolve in water. All right? So cohesion is attraction between molecules of the same substance. Adhesion is going to be attraction between molecules of different substances. Now, cohesion and adhesion are properties of water that are going to have a major impact on their ability to move through plants, to move along surfaces, and things like that. So it's a major important property of water is the cohesion between water molecules. A mixture is a material composed of two or more elements or compounds that are physically mixed together but not chemically combined. Mixtures that can be made with water are solutions and suspensions. So if we take a look at this next slide right here, where we see solutions and suspensions, a solution is when all components are evenly distributed throughout. The solute is the substance that will be dissolved, and the solvent is the substance that the solute is dissolved into. So take a look right here. That picture at the bottom shows that sodium chloride, NaCl, is being dissolved into water. Okay? Now, the negatively charged chlorine molecules and the positively charged sodium molecules are both being interacted with differently. Notice that the chlorine molecules have the positive end of water attached to them, and the positive sodium molecules have the negative end of water attached to them. This polarity is very important in terms of dissolving. Substances that are nonpolar, such as oils, fats, grease, things like that, those aren't going to dissolve in water. All right? If you think about it, if you spill salad dressing on your clothes, are you just going to put water on it to get it out? No. You're going to want to use another non-polar substance. Polar water is not going to be able to take out a non-polar substance. So you use something like dish detergent, which is non-polar, is going to break up that grease. Okay? The same reason that you put wax on your car. Wax is non-polar. Okay? So if you never notice, water will just sit right on top of it and drip right off. All right? So using the non-polar wax on the car keeps the water from, laying flat on it. It keeps it beaded up, and it comes right off when you start driving. Now, pH. Water molecules can react to form ions. To show this, you use a double arrow to show that the reaction goes in both directions. Now, the pH scale determines the concentration of H+ in a solution. The pH scale ranges from 0 to 14, with 7 being neutral. Okay, 7 is in the middle, it's neutral. 0 is highly acidic, 14 is highly basic. So if we look right here, acids are going to be any compound that forms H+ ions in a solution. Acids have a pH less than 7. So if we look at this chart right here, they are in the red, orange, and yellow colors. Right? Bananas are going to be acidic, but they're not very acidic. Okay? But very acidic, battery acid, has a pH of 0. It's very acidic. Okay? So the lower the number, the more acidic it is. The further from 7 it is, the more acidic it is. Now, bases are any compound that can form OH- ions. Bases have a pH greater than 7. So again, you look, liquid drain cleaner at a pH of 14 is going to be the most basic. So the further you are from 7, which is listed here as pure water, the more acidic or the more basic you are going to get. And finally, buffers are weak acids or weak bases that can react with strong acids or strong bases, and they're going to prevent sharp, sudden changes in pH, right? They help to slowly change the pH as opposed to a drastic, quick shift. Okay?